Hello, my name is Eric Schuler. I am from the College of Information Research and Analysis Lab at the University of North Texas. In this video tutorial, I'll walk you through an assessment of univariate outliers in SPSS using a heuristic data example. In this heuristic data example, I was interested in seeing if there were differences in how much someone loved statistics on the scale from 0, meaning run away, to 100, being head over heels for statistics, between graduate students and faculty members. I pulled 17 individuals, and I also asked them on a scale of 0 to 100 how much they loved research methodologies. We will look at this variable in our multivariate outlier tutorial later on. I hypothesized that there would be differences in the mean scores of loving statistics between these two groups, but I'm not quite sure what direction, so I'll need to run a two-tailed independent samples t-test. Now I'm going to go click on the variable view to show you the variables of interest. The first one we have is participant. This is simply our participant ID number. We also have role, which is going to be dummy coded as either 1 being a graduate student or 2 being a faculty member. We also have our variable love statistics, which is simply how much on a scale of 0 to 100 the individual reported that they love statistics. In research D is the report of how much individual loves research designs. And this is the data set that we have. Now I transcribed this data from pen and paper surveys, and here's what it looks like. Since I'm running an independent samples t-test, I will need to assess outliers for both groups individually. This is based on the recommendations of Tabachnik and Fidel 2007. An easy way to do this is to go to Data, then click down to Split Cases, or Split File. Now an easy way to do this is to go click on Data and then click on Split File. From here I'm going to click on Compare Groups and move Role into Groups Based On. This will split our analyses by group whenever we run them for now. So what I'm going to do is I'm going to copy this into my syntax. I highly encourage using syntax. It helps if you lose your output, they can help recreate everything. From here I'm going to add a comment, letting myself know later on what exactly I did. So I'm going to write down cases by role. This way, in case I come across a syntax a couple months from now, I know exactly what I did at each and every step, rather than having to start over from scratch. Now I'm going to go to Analyze, click on Descriptive Statistics, Explore. I'm going to move Love Statistics to the dependent list. Then I'm going to click on the statistics blocks, and this looks all great, so I'm going to click on Continue. Next I'm going to go to Plots, and I'm going to select the histogram, click on Continue, and I'm going to request both the statistics and the plots. Now this will print out some box plots and allow me to look at the sample statistics for each group. And next I'm going to click on Paste, and then this will copy this into my syntax. Now I'm also going to add a little comment to myself as well. So I'll write down Explore Univariate Properties. Now on my syntax, we have our split file, and we can get our descriptive statistics. So I'm going to highlight both of these and click on Run. Now as we can see, we already have a warning. This is interesting, so let's look into this. So we have a 0. Now, I should only have 1 for graduate students and 2 for faculty. So I'm going to go back to my paper copies that I transcribed from and see what's going on here. Because based on the data set, when we look at it, we have a role of 0, which we should not have. Upon a closer review, I find that this case 17, participant 17, which had a 0, was actually an undergraduate student. Since they're not for my population of interest, I'm going to go ahead and delete this case. After leaving this case, I'm going to reopen my syntax and rerun it. Now just for clarity, I'm going to go ahead and remove this previous one. Now let's take a look at our output. For graduate students, as we can see, it's been split, so we have 8 graduate student participants and 8 faculty participants. And we can see that descriptive statistics have been printed out based on this 2 different rules. Now graduate students had a mean score of love statistics of 88.63 with a standard deviation of 5.63, and there was a median of 89. Now in the faculty sample, we saw that there's a mean of 68.75, a standard deviation of 68.04, and a median of 93. Now something is a little off here. This is a very, very large standard deviation for the faculty group. Now remember from the research tip that means, standard deviations, and variances are all susceptible to extreme scores or outliers. Now I'm going to take a look at the skewness and kurtosis for both groups. Graduate students looks okay. The skewness was 0.379 with a kurtosis of negative 0.603. Now for the faculty sample, it looked pretty skewed. There was a negative 2.786 for skewness, and the data was not normal for the faculty sample, with a 7.814. Now I'm going to scroll down, and I'm going to look at the box plots. This first box plot is going to be the box plot for graduate students. As we can see, there's no extreme cases below or above the whiskers. Now let's take a peek at the faculty. As we can see that there's a case that's far removed from the lower threshold. So case number 15, which actually had looks like it's going to be a negative number, which we know is not quite possible because the scale goes from 0 to 100. So let's go back to the data view for a second. So look at case 15, and they had a love statistics of a negative 99. Since this isn't possible since we have a minimum score of 0, this is probably a data entry error. So at this point, I'm going to go back to the hard copies of the surveys and take a look to see if maybe there was a transcription error. Upon further examination, I found that for case 15, the love statistics score should have been a 92, not a negative 99. This was an error when I was transcribing the data from hard copies into SPSS. So I'm going to go ahead and change that to a 92. That way I can correct the value, and I'm going to rerun the descriptive statistics. Now, rather than having to go through and click Analyze again, what I'm going to do simply is going to go back to my syntax and then highlight and run this examine again. Now, since this change was done with the faculty group, we're not going to see any changes based on the graduate student group. We still have a mean of 88.63, a median of 89, and a standard deviation of 5.63. The skewness hasn't changed, nor has kurtosis. However, because we've removed that error in the data set for the faculty group, we can see that our mean, standard deviations, and potentially skewness has changed as well. Now we have a mean for faculty of 92.63 for love statistics, a median of 93, and a standard deviation of 5.975. You can also see that the skewness is a little bit better, but still slightly skewed and a little non-normal, with a skewness of negative 1.40 and kurtosis of 2.65. However, based on the recommendations of Glassnap and Paggio, 1985, these are within acceptable ranges. However, I'm still going to calculate some standardized scores, or z-scores, for love statistics to see if there are any values that are larger than the absolute value of 2.5 standard deviations of the mean. However, since the mean is very susceptible to being biased by extreme scores, I'm actually going to be using the median to calculate z-scores instead. We will continue with the next part of this tutorial in the next video. Thank you.